Okay, so this is a quick review of different operations that you can do with radicals or roots. So specifically, we're going to discuss addition and subtraction with radicals, multiplication and division with square roots. So just FYI, before I get into this, you should know the basics of radicals. So what I mean by that is that you should know how to simplify radicals that look like these four here. If you're saying, I don't know how I would begin simplifying those, don't worry, I've got you. I have a video where I talk about a quick review of radicals. So I'd recommend that you go and check that out first before you watch this one, because I'm assuming you've already got that. Okay, so the first thing that we need to discuss is the concept of like radicals. So like radicals are very similar to like terms. So like radicals require that you have the same, what we call it, index, and then the same number underneath. So for instance, I have here square root of 5. So what I am looking for is for any other term that might have the square root of 5 with it. So as I look through here, so I have 6 times the square root of 5. I know it's at the bottom of the screen, so it might be a little harder to see. But these two would be considered like radicals, okay? Now you might also be looking over here at x times the square root of 5. So this would be a like radical, but it's not a like term. So only like radicals can be added. So these two could be added. This could not. So I will exclude it for now. However, if I were to take a look at this, so this does have something that it could be added to. So this could be added to this one right here. So these both have the like term of x, and then they both have that square root of 5. So that's what we're looking for. So if I want to keep going with this idea, so let's say that I've got 6 times the cube root of 7. So does this have anything that it pairs with? So as I look through everything, this would pair with this one over here. So this would be like radicals right here. What about negative 2 times the square root of 3? I'm using a fun pen here. I have this cool galaxy looking pen. Okay, so anything that this would pair with, it would pair with the square root of 3. So those two go together. Oh, that pen's kind of fun. Let's see, can I use it again? Oh, I can use the pen again. Let's use it. Okay, so I've got 7 and the cube root of 5. Any place I can match that with would be this 3 and the cube root of 5. So those two could be added because they have like radicals. And then what about these? So I've got 2x times the cube root of 5 and 2x times the cube root of 5. So this is actually the exact same term, but yeah, these are technically like radicals. Okay, so only like radicals can be added or subtracted. So that's why we just spent all that time doing that. Plus I got to play with fun pen options in Microsoft, so that was great. So yeah, so only like radicals and like terms can be added and subtracted. So once you kind of get that, the rest of this really comes together. So if I look at this expression here, so what could actually be added? So this 4 square root of 5 and this 7 square root of 5 could be added. So when that happens, all you're going to do is add the terms in front. So you're just going to take the 4 plus the 7. 4 plus 7 is 11, and then the square root of 5 just comes along for the ride. Now, what about these other two terms? I have 3 cube root of 5 and 2x cube root of 5. So unfortunately, these are not like terms because this one has an x and this one doesn't. So if I were trying to add this up, I would just have to let these kind of trail off on the end, and that's just how it's got to go sometimes. Okay, so let's take a look at the next one then. So I've got the square root of 24 plus 5 times the square root of 6 minus 2 times the square root of 3. So the other fun thing when you're doing this is that sometimes you might have to actually simplify some of the radicals. So specifically the square root of 24, that can be simplified. So I can break the square root of 24 into 4 times 6. So again, I'm assuming that you are familiar with that technique. If you are not, I recommend you jump back to the other video. So then this will be simplified to 2 times the square root of 6 plus 5 times the square root of 6 minus 2 times the square root of 3. And now you can see these two are like radicals. So I'm going to rewrite this as 7 times the square root of 6 minus 2 times the square root of 3. Okay, so I have 2 more here, and what I would recommend is that maybe you just pause for a second and try these 2 on your own, because then we're going to move on to the next topic. So let's just make sure that you've got this and that you give it a try. Okay, so for this next one, so this will simplify to 2 times the square root of 4 times the square root of 2x. The other radical will not simplify. So this becomes 2 times 2 times the square root of 2x minus 5 times the square root of 2x. And that will equal 4 times the square root of 2x minus 5 times the square root of 2x. So then 4 minus 5 is just -1. So this will be -1 times the square root of 2x. And for the other one, so now we have cube roots. So the largest cube that will go into 81 is 27. So I can break this down into the cube root of 27 times, the cube root of 27, and also this x to the 5th can be broken down as well. So I can actually bring x to the 3rd under this radical. Again, I talk about that at length in my other video, so just for the sake of time, I'm not going to go through all that again. So let's see. So I've got all of this broken down like so. So now I can go ahead and simplify this part here. So this becomes 7 times 3x times the cube root of 3x squared plus 2x times the cube root of 3x squared. So 7 times 3 is 21, plus 2 will make 23. So this will be 23x times the cube root of 3x squared. And so that'll be how that one goes. Okay, so that is addition and subtraction. Actually, if you want more practice on that, you can check out my extra practice video, but I'm going to move on to multiplication. So for multiplication, there is a rule that we've really been using with radicals that we just need to formally state here, which is, okay, so here's how multiplication with radicals works. If I have the nth root of a times the nth root of b, basically I can just multiply those numbers together. So at the end of the day, as long as they have the same index, that's what this is called, right? As long as they have the same index, then the numbers underneath can be multiplied together. So that is important for this next set of exercises because we're going to practice first distributing, and then of course I'll make it harder. So if I have like a problem like this one, so square root of 5 times everything in here, well, all of these have a square root, so I can just multiply the numbers under the square root together. So what this is going to become is, so 5 times 2 is 10. Now this 5 is on the outside. Let's see if I can draw a better 5. This 5 is on the outside, so I can just leave it on the outside, and I can just take 5 times 7, which is 35. So that's the basic idea behind this. So of course, this can get a little bit more interesting. Say we look at example B here. So now if I were to multiply these things together, so this would become the square root of 50 minus 2 times the square root of 75. And so now the thing that's different between this example versus this one is that this example has radicals that can be simplified farther. And that's what you're going to have to watch out for when you are doing multiplication problems. So this will simplify then into 5 times the square root of 2 minus 2 times 3 times the square root of, 2 times 5 times the square root of 3. So ultimately this will equal 5 times the square root of 2 minus 10 times the square root of 3. So you have to always ask yourself if you can simplify the radicals farther. Okay, now let's get to something even more interesting. So if you know how to multiply polynomials, if you remember like foiling, this should also kind of carry over. So in this case now, I have to FOIL out these two radical expressions. And so the idea behind this is that I just want to multiply everything in here by everything in here. And so if you have been a little rusty on this, what I usually like to do to get started is I like to just draw little lines so that I can track what I'm doing. So I'm taking square root of 2 times square root of 5, so that's going to be square root of 10. And then square root of 2 times square root of 7, so 2 times 7 is 14, so this will be the square root of 14. Okay, so continuing on, so I've multiplied everything by the square root of 2 in this one. So now I'm going to move on to the square root of 3. So I'll take the square root of 3 times 5, so that's going to be the square root of 15. And then I'll take the square root of 3 times the square root of 7, so that's going to be the square root of 21. And so this really is the answer. I can't simplify this anymore. So I just leave this as is. I'll just write it without all the colors just to make sure you can see it. But that's the general idea behind it. Now, of course, anything could happen though. It could be that you might actually have to simplify some of these radicals. And of course, that's where this is going, is that you are going to have to simplify some radicals. Now, in the event that you are watching this because you really need to remember how to do this, I would recommend that you pause here, give this a try. You'll get way more out of this if you try it on your own. So pause here, give it a try, hit play when you're ready. Okay, so using that same procedure from before, so I'll take the square root of 2 times the square root of 10, so that's going to be square root of 20, square root of 2 times 3 times the square root of 6, so the 3 is just going to hang out, and then we've got the square root of 18. So now I've multiplied everything here by everything in here, so now I need to multiply everything by the square root of 5. So square root of 5 times the square root of 10 is going to give me the square root of 50. Square root of 5 times 3 times the square root of 6 will be 3 times the square root of 30. Cool. So now we just have to look through and see what can we actually simplify further. So for instance, square root of 20 can 100% be simplified. So this would be the square root of 4 times the square root of 5. Let's see. Square root of 18 can be broken down. So this will be the square root of 9 times the square root of 2. The square root of 50 can be broken down into square root of 25 times the square root of 2. And the square root of 30 cannot be broken down further. So here's everything that I can break down. So my final answer will be 2 times the square root of 5 plus 3 times the square root of 2 plus 5 times the square root of 2 plus 3 times the square root of 30. So just to finish this off, so this will be 2 times the square root of 5, 9 times the square root of 2, 5 times the square root of 2, and 3 times the square root of 30. Okay, so now the other thing that I want to talk about are working with when you have a square of a radical expression. So the key with a problem like this is to remember that you don't just get to simply square these two things. So the first thing that you want to do is rewrite this as square root of 3 minus the square root of 5 times the square root of 3 minus the square root of 5. So actually buried in this, you do have to FOIL this out again. And so from here, if we want to FOIL this out, this becomes the square root of 9 minus the square root of 15 minus the square root of 15 plus the square root of 25. And so now you can see that we can simplify some things. So this will be 3 minus 2 times the square root of 15 plus 5. So this is 8 minus 2 times the square root of 15. And I can't do the 8 minus the 2 because the 2 is attached to the square root of 15, so they're not like radicals, like terms, whatever you want to think of it as. So I have another one here. So I strongly recommend that you try this one on your own. I've got just a couple more examples like this, and then we'll switch topics again. So give this a try. Let's make sure you've got it, and then hit play when you're ready. So I need to take the square root of 3 plus the square root of 6, square root of 3 plus the square root of 6. So this is going to be the square root of 9 plus the square root of 18 plus the square root of 18 plus the square root of 36. So this is 3 plus 2 times the square root of 18. So the square root of 18 can be broken down into the square root of 9 times the square root of 2. So I'm just going to set that up right now. And then I've got plus 6. The square root of 36 is 6. So this is going to turn into, so let's see, I've got the 3 plus the 6, so that's 9. And then this is 2 times 3 times the square root of 2. So my final answer will be 9 plus 6 times the square root of 2. Now, just to make things a little bit more interesting, I'm going to put some numbers on the outside now, just so we can make sure that we feel good about how to multiply with this. So let's say that I've got 2 times the square root of 5 plus the square root of 10. So I know that I need to set this up so that I can FOIL it out like that. And okay, so now let's multiply it all together. So the only thing with this, and this is what can kind of throw people off, is so now you have to pay attention to these numbers on the outside as well as these numbers on the inside. So notice for this first set of multiplication, taking this times this. So I'm going to have the 2 times the 2, which is 4, and then the square root of 5 times the square root of 5, which is the square root of 25. So you just want to be careful with that. And then continuing on, I'm going to have 2 times the square root of 50 plus 2 times the square root of 50, and then the square root of 100. So from here, now I can break a few things down. So this is going to become 4 times 5, and then I have 4 times the square root of 50, and the square root of 50 can be broken down more, and then plus 10. Okay, so now I'm going to have 4 times 5 is 20, plus the 10 is 30, And then this part here can be broken into the square root of 25 times the square root of 2. So this is going to equal 30 plus 4 times 5 times the square root of 2. So ultimately this is 30 plus 20 times the square root of 2. And so as you can see, there can really be quite a bit of work in these problems. They're actually not necessarily like simple problems. A lot of them have a lot of work. So I have one more like this that I think is kind of tricky. So again, I have numbers on the outside and numbers on the inside. So I would strongly recommend that you pause here, give this a try, and then hit play when you're ready. Okay, so I'm going to give myself a little more space this time. So I'm going to have 4 times the square root of 6 minus 2 times the square root of 10. 4 times the square root of 6 minus 2 times the square root of 10. Okay, so let's multiply this together. So I'm going to have this term times itself. So 4 times 4 is 16, and the square root of 6 times the square root of 6 will give me the square root of 36. Now taking 4 square root of 6 times negative 2 square root of 10, this is going to be negative 8 times the square root of 60. And then we'll have that again, negative 8 times the square root of 60. And then finally for the last terms, so I have this times this. So this is going to be 4 times the square root of 100. Okay, so let's keep going with this. So I'm going to have 16 times 6 minus 16 times 60, square root of 60, plus 4 times 10. Now the square root of 60 can be broken down, and let's see, so 16 times 6 is 96. Let's see, square root of 60 can be broken down into square root of 4 times the square root of 15, and then 4 times 10 is 40. So I have, let's see, what is that? 136 minus 16 times 2 times the square root of 15. So this is going to be 136 minus 32 times the square root of 15. Okay, and so now we're going to pivot over to division with radicals. So I'm going to show you 2 different ways that this can look. There's actually other types of division, but just for the sake of like review, I'm going to do kind of the 2 most popular types. So the first one is, what do you do when you have a radical in the denominator? So this, we could call this division, or we could just call this like, basically you can't have a radical in the denominator. So the process here that we call this rationalizing the denominator. So sometimes it comes up as radical division, other times we call it rationalizing, tomato, tomato, I guess. But okay, anyways, so rationalizing the denominator when you have 1 square root in the denominator is actually pretty straightforward. All you have to do is multiply by the radical in the denominator on the bottom, and whatever you do to the bottom, you do to the top. So let me get rid of the, let me give myself some space. Okay, so let's work this out. So what does this become? This becomes 4 times the square root of 5 over the square root of 25. And so this will be 4 times the square root of 5 over 5. Now, a lot of times what people remember is that like the square roots cancel each other out. It's not that they're really canceling each other out. It's that when you multiply these numbers together, it just ends up equaling the same number underneath. So the reason I mention that is because this is different if you have higher radicals. So for cube roots or 4th roots, this doesn't work the same. I'm not covering that in this video, but this is like a trick that is really easy for square roots and gets harder when you have higher roots. So that's all I want to say. Now, in this case, I have square root of 3 over square root of 5. So you only need to multiply by the thing that's in the denominator. So in this case, I'm just going to multiply by the square root of 5 on top and on bottom. And in this case, I will get square root of 15 over the square root of 5. Now, one other trick that I want to throw out here is that when it comes to radicals, you are allowed to break up radicals into pieces. So what I'm saying is that the square root of 7 over 10 can be broken up into the square root of 7 over the square root of 10, and then you can rationalize. So I'll go ahead and just multiply by the square root of 10 on top and on bottom. And so this will become the square root of 70 over 10. And so moving on to D here, so I have 2 times the square root of 5 over the square root of 6. So once again, I'm just going to multiply by the square root in the denominator. Multiply this out, so I have 2 times the square root of 30 over the square root of 36, which will of course equal 6. But the plot twist with this one is that 2 goes into 6 3 times. So this whole thing will actually simplify to the square root of 30 over 3. So you do have to watch out for other simplifications, of course. Now, the last thing that I want to talk about is the idea of the conjugate. And this is something that we're going to need when we have 2 square roots in the denominator. So before I had 1 square root in the denominator, and now we're going to move on to 2 square roots in the denominator, which is honestly also like a pretty simple case to deal with. So all the conjugate is, and I'll show you why we need it in a second, but all the conjugate is you just take whatever sign is in between your 2 terms and you flip it. So for instance, if I have 4 plus the square root of 3, I'm going to rewrite the conjugate as 4 minus the square root of 3. Or if I have 2 minus the square root of 6, square root of 2 minus the square root of 6, I'll rewrite this as square root of 2 plus the square root of 6. So it doesn't matter what sign is here, it's just the sign in between. And so in this case, it's going to be negative square root of 5 plus the square root of 7. And then for this last one, so just to finish driving this concept home, this will be square root of 7 plus 2. So you just change whatever sign is in the middle. And so the conjugate is what we're going to use to get rid of the square root in the denominator, or again, to rationalize the denominator. So if I have something like 5 over the square root of 2 plus 3, so I know this one doesn't have 2 square roots, but it has the square root and another number. So when you run into a case like this, you multiply by the conjugate, and this will be how we get rid of the square root. So I'm going to write this on top and on bottom like you see here. So the thing with this now is that I am going to have to FOIL all this stuff out. So we need to be able to multiply our radicals pretty well for this. So this is going to equal 5 times the square root of 2 minus 15 on top. And then let's work out the bottom. So this is going to be the square root of 4 plus 3 times the square root of 2 minus 3 times the square root of 2 minus 9. And so this is exactly why we like the conjugate. So the way that the conjugate is designed is that you will always have kind of these middle terms of weird radicals. They will always end up canceling each other out. So these two drop out. So what am I left with? I am left with 5 times the square root of 2 minus 15 over 2 minus 9. And so that's going to be 5 times the square root of 2 minus 15 over negative 7. And from here, it's a little bit of like an aesthetic thing. You could either leave it at this, or you could break this into 2 separate fractions. So in this case, now I'm going to have a negative over a negative. So this will become 15 over just 7 because it's a negative over a negative. Okay, so let's try that again. And I would actually recommend that maybe you try this one on your own, of course. So give it a go. Hit play when you're ready. So I'm going to go ahead and multiply by the conjugate. So I don't know why, but I always have so much trouble making 5s. And for whatever reason, I always want to make 5s in my content. It's like this like weird like number that I always end up using. Okay, so the top part of this is going to be 6 times the square root of 5 plus 6 times the square root of 2. Now, once again, we need to FOIL out this bottom part. So this is going to be the square root of 25 minus the square root of 10 plus the square root of 10 minus the square root of 4. Okay, so as you can see, the square roots of 10, these drop out. So I'm left with 6 times the square root of 5 plus 6 times the square root of 2. And in the bottom, I get 5 minus 4. So this actually equals 1. So I actually don't even need the denominator in this case, and this will just equal 6 times the square root of 5 plus 6 times the square root of 2. Okay, so the next thing that we want to watch out for is, of course, you might have to also simplify radicals. So for this one, just be ready to simplify some radicals. Of course, I have to make it more interesting. This is good practice for you. Pause here, give it a try, hit play when you're ready. Okay, so this is going to be square root of 6 minus square root of 2, multiplied on the top and on the bottom. So this is going to be on top, square root of 18 minus the square root of 6. And in the bottom, this is square root of 36 plus square root of 12 minus the square root of 12 minus the square root of 4. And so these square roots of 12 cancel each other out. Now, the square root of 18 can be simplified. So this will be simplified into 3 times the square root of 2, right? Because 18 is 9 times 2, and the square root of 9 is 3. So I can rewrite it like this. Cannot simplify the square root of 6. And then here, this is just going to simplify to 6 minus 4. So in the end, I have 3 times the square root of 2 minus the square root of 6, all of this over 2. And you can break that into 2 separate fractions if you would like. And for the last one, we'll call this one Foil Palooza, foil all the things. So as far as like, what are you going to multiply by? So it's still the bottom driving everything. So I've got the square root of 2 minus the square root of 5. Whatever you do to the bottom, you have to do to the top. So now we got to multiply all this fun stuff together. So this one is a little bit challenging, but it's a great one just to make sure that you really have all the multiplication and division and all that good stuff down. So I think this is a great one to end on. So try this one, hit play when you're ready. So this is going to be the square root of 10 minus the square root of 25 plus the square root of 12 minus the square root of 30. So that's the top part. The bottom part will be the square root of 4 minus the square root of 10 plus the square root of 10 minus the square root of 25. So these square roots of 10 will cancel out. And then in the top, so now there's some simplifying to do. So of course, square root of 25 we can simplify, square root of 12 we can simplify. So this will be the square root of 10 minus 5 plus 2 times the square root of 3 minus the square root of 30 over 2 minus 5. And I am running out of space here, so I'm just going to rewrite this 2 minus 5 as negative 3. And so that will be the final answer. Of course, you could break it up into other fractions if you needed to. Now, I try to keep these review videos shorter. This one got a little bit longer, but there was a lot that we covered. But you might feel like you still need to see more examples to master this material, and so don't worry, I've got you if that's the case. Every review video comes with a practice problem set. So the practice problem set is a PDF with an answer key, but also worked out video solutions. So however you want to get this content, it's up to you. So just go to dividingconquermath.com and go to the review section. By the way, you can't learn math by watching a ton of YouTube videos. You do really have to practice it to master the skill. So please use these resources that I've created in a way that will really help you. And by the way, my review series has many other topics in it. Each topic works exactly like this. It's got the refresher video, practice problems, answer key, all that good stuff. So it's all at dividingconquermath.com. Go to review and everything will be there for free. And otherwise, I'm going to leave it at that, guys. I'll talk to you in another video. Peace.